Alright, so this is the third part of this video, going over the similarity review, similar figures quiz review. Got two triangles, AHB, JLK. I want to prove that AHB is similar to JLK, and I want to figure out which of these I can use, which of these facts down here will allow me to prove that AHB is similar to JLK. Let's start with this. Well, let's start with thinking, what are the things that we could use to prove that two triangles are similar? We've got AA, we've got SSS, and we've got SAS. Angle, angle, side, 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 angle, side. Okay, well, what do we know so far? Look at the picture. We've got this and this. They're two right triangles. These two angles are 90 degrees, so we've got one pair of angles that are congruent. Angle H is congruent to angle L. If we look over here at our theorems, that means that either we're going to have to find another angle for AA, or we're going to have to find two sides to do side angle side. The thing to remember, though, with side angle side that's tricky is that the angle here, it's in between these two sides for a reason, because the angle that we're looking for is the included angle, the angle between the two sides that we know are proportional. Okay. So, starting with this, angle A is equal to angle B, and angle J is 30 degrees. So that would be like if we do this, angle A and angle J are congruent, angle B are congruent, and angle J is 30 degrees. Well, this looks like, if anything, it's going to be angle, angle. We've got one angle. Now, do we have another pair of angles, corresponding angles that are congruent? No. We just know that the two angles in the triangle are congruent, but we don't know that this is 30 degrees. We don't know that either of them is 30 degrees. In fact, if we know that they're the same, then they have to each be 45, because they'd have to add up to 90. So, this one isn't going to work. Alright, let's erase all that. Check again. Angle A is congruent to angle J. Would that be enough? Okay, then we'd have this and this. Oh, now we've got corresponding angles. One pair of corresponding angles, another pair of corresponding angles. So yes, this will work by angle, angle. The angle, angle theorem will tell us that they're congruent. That they're similar. The two triangles are similar. All right, moving on. AH over JL equals AB over JK. So AH, that's here. JL, okay. AB, JK. Okay, so we've got corresponding sides. That gives us two pairs of corresponding sides and an angle. So can we use SAS? No. Why not? Because the angle, so we would have AH and AB and JL and JK, but we would need, in order to use those two sides and SAS, we would need the included angle, which would be A and J. But we don't have that. All we have is that H and L are congruent. So this won't work. Go try this one. AH and JL, okay, again, and LK and HB. This looks good because AH goes with JL and LK goes with HB, and the side that the angle that's included would then be angle L and angle H. Okay, those are congruent. But what's the problem here? Well, you probably saw when I was doing it. Look, AH goes with JL, and then LK goes with HB. Well, if we were going to use this ratio, these sides, wouldn't we want to have these flipped? Right? Wouldn't we want to have HB over LK? Yeah, because AHJL, right, we got the left-hand triangle on top here, so we have to have the left-hand triangle on top over here as well. We don't, so this doesn't work. Last one, AHJL, HB, LK. Oh yes, this is what we wanted to have over here, but now we've got it here. We've got two sides, side, and then we've got the included angle, the angle in between those two sides, right? Because on this triangle we know about AH and HB. On this triangle we know about JL and LK. And the angle between AH and HB is H. The angle between JL and LK is L. And we know that L and H are congruent because they're both 90 degrees. So by SAS, that one works. Okay. Quickly, these last two, we've got a bow tie it doesn't really matter what the bow tie looks like, but let's say it's 2 inches tall and 5 inches long. And then we've got the statue, and the statue is going to be 16 feet long, so it's going to be 16 feet here. Okay, well, so 2 to, and it asks us how high will it be. Okay, 2 to x should equal 5 to 16. 2 over x equals 5 over 16. 2, so then I've got 5x equals 2 times 16 is 32, so x equals 32 divided by 5, which is, I believe, 6.4 feet. Now, some of you will be thinking, well, you used inches over here and you used feet over here. Would you get the same answer? Shouldn't you convert these to feet or these to inches? You could. You'll get the same answer. You'll get this answer in inches. If you don't believe me, give it a shot. All right, I'm going to move on. All right, solve for x using the picture below. I'm just going to write it in. So I've got AED is similar to ABC. So the overlapping triangles again. I've got DE is 9, CB is 17, AD is x, DC is 6. Okay, again, draw the triangles separately. I've got x and 9, then I've got x plus 6 and 17. Now I set up my ratio. X over x plus 6 equals 9 over 17. So I get 17x equals 9x plus 9 times 6 is 54. Remember, I have to distribute. Subtract 9 from both sides, I get 12x equals 54. And I divide both sides by 12. X equals 54. I'm sorry, that's not 12. 17 minus 9, that's 8. So, anyway, so divide by 8 over here, 54. 54. Clear. 54 divided by 8 is 6.75. Done.